Chapter 9, electrons in atoms and the periodic table. That's not electrons in the periodic table, but two topics, electrons in atoms and the periodic table. It just struck me as funny. You guys seen this picture before? What is that? The Hindenburg. May 6, 1937, the Hindenburg burst into flames, killing 36 of the 97 passengers. I think it's actually amazing it didn't kill everybody, right? They had just come across the Atlantic Ocean and were landing in the United States, and I don't know if they've ever really figured out what happened. Some sort of static electricity or something, but just as it was landing, it burst into flames. It was filled with hydrogen. Hydrogen is the lightest gas, but it's also very flammable. And you know, humans have learned from this tragedy that it's not a good idea to fill a dirigible with hydrogen gas. And now they use helium instead. Works out much better. So, hydrogen, we know that it's flammable, it's reactive. Why? Why is hydrogen so flammable and so reactive? You don't have to answer that. So modern blimps are filled with helium. Helium doesn't burn. Helium doesn't react with anything. There is no known compound of helium with another element. Just doesn't make compounds. Why? Helium is inert. It doesn't react. Why? So in this chapter, we're going to learn about some models that help us to understand and explain why helium is inert, but hydrogen is very flammable. Hydrogen and helium are right next to each other in the periodic table. They're very similar in size, and yet they have very, very different chemical properties. Other elements also vary in their reactivity. Are there other elements as reactive as hydrogen? Yes, there are. The other elements in group 1, such as lithium and sodium, are very reactive. In fact, a couple of students in the class were kind of intrigued by this last week in lab, and were looking stuff up and watching YouTube videos of sodium being thrown into a lake and just all kinds of mayhem from elements reacting. And other elements, like the other noble gases in group 8A, are very inert. Neon, argon, krypton, xenon, radon, those are all very inert gases. They're not going to explode. It's difficult to make them have compounds. And so the models and theories that we're going to learn about help us to explain and understand the behaviors of these different groups of elements. It's not a coincidence that all of the group 1A metals plus hydrogen are very reactive and the group 8A noble gases are inert. That's not a coincidence. There's a reason behind that. So we're going to look at two models, the Bohr model and the quantum mechanical model. And these both propose explanations for why helium is inert and hydrogen is it's not radioactive, it's reactive. And these also help us to understand the periodic law, which was the principle by which Mendeleev arranged the periodic table. So, review here, periodic law, when elements are arranged in order of increasing atomic number, certain sets of properties recur periodically. And reactivity is one of those properties. So we're going to look at how electrons are arranged within the atom and how the electrons affect the chemical and physical properties. It's really the electrons where all this stuff happens. When we get to quantum mechanics, it's kind of a hard thing to get your mind around. And so you're in good company. Niels Bohr, very famous scientist, Erwin Schrödinger, and of course you've heard of Albert Einstein and you know what he looks like. So these are some quotes from these guys. Anyone who is not shocked by quantum mechanics has not understood it. Quantum mechanics is shocking. It just doesn't make sense. Erwin Schrödinger said, "I don't like it, and I'm sorry I ever had anything to do with it." So, you know, these great scientists are trying to figure out what's going on inside the atom and how things work, and they're disturbed and unhappy about what they found because they can't explain it very well. And Albert Einstein's response was, "God does not play dice with the universe." So I just find those quotes to be very amusing. The quantum mechanical model is foundational to modern chemistry. That is our current understanding of what's going on inside the atom. It forms the basis of the modern periodic table. What's interesting is the periodic table was put together based on observations of size and reactivity and other things like that. We did not even know about what was going on inside the atom at that point. Pretty sure that was before electrons and protons and neutrons were discovered. But this arrangement, after discovering quantum mechanics, makes perfect sense for the arrangement of the electrons. And so it's really, the periodic table really is a wonder. It's just amazing. Because we have the periodic table and this understanding, we can develop new drugs. We can use semiconductors to make computers. I mean, the fact that most of you have smartphones in your pockets. A lot of you are young enough that I don't think you realize how amazing those things are. I grew up watching Star Trek reruns, the original Star Trek with, William Shatner, right? And they had these comm link things on their wrists. And that was just like, how do you do that? You know, it's not a telephone attached to the wall, and they're talking to each other and all this crazy stuff, and it was science fiction. We are living science fiction now. It's absolutely amazing. And part of it is due to understanding chemicals and elements. And the semiconductors are critically important in being able to have computers. So this is very relevant to everyday life.